Good day, class. I'm here to take the course ECN209, Mathematics for Economics. Officially, myself and Professor Adam Akperon of Economics Department, we are located to take the course. My own name is Babatunde Adesoya. Just a recap of what we did in the last class. I introduced the course outline, and among the course outline is the derivative of trigonometry ratio. We have the input and output analysis. We have the linear algebra. Then we will have the derivative. We have the total and partial derivative. And for today, we'll be dealing with the topic derivative of trigonometry ratio. At the end of the class, the students will be expected to be able to prove the derivative of basic trigonometry ratio. And just before we go into the basic trigonometry ratio, I would like to introduce us back to the concept of derivative. A review. We'll start with the function notation. If we have y is the function of x, u function of x, v function of x, s function of t, then we can have the derivative notation as y prime as function of f prime x equal to dy dx equal to the function of x dx equal to the function of y equal to d subscript x function of x then equal to d subscript x y. Then we'll quickly go into the last one, which is the x prime. X prime equals to x function of t, which is equal to the s the t equals to the s function of t equals to ds equal to the d subscript c function of t then equal to d subscript x. Now we'll go into the next slide, which is the basic derivative of the basic trigonometry function. We have three basic trigonometry ratio. We have the sine, we have the cosine, and we have the tangent. And their reciprocals are cosecant, we have the secant, and then the cotangent. Now their derivative. The derivative of sine theta, if for instance y equals to function of theta and equal to sine theta, then the derivative of the function will be y prime equals to the y dx equal to cos theta. Then for cosine, if a function is given as y equal to function of theta equals to cos theta, then the derivative of the function will be y prime equal to the y dx equal to minus sine theta. Then for tangent, if the function is given as tan theta, then the derivative will be y prime the y equal to the y dx equal to sec square theta. Now their respective reciprocal, like I've mentioned earlier, the reciprocal of sine theta is cosecant theta. If a function is given as y equals to secant theta, then the derivative of the function will be y prime equal to dy dx equal to minus cot theta cosecant theta. Then the reciprocal of cosine theta, which is the secant, if a function is given as y equal to secant theta, then the derivative of that function will be y prime equal to the y dx equal to tan theta multiplied by secant theta. Then the last reciprocal, which is the cotangent, which is the reciprocal of tangent theta. So if a function is given as cot theta, y equals to cot theta, then the derivative of that function will be y prime equal to the y dx equal to minus cosecant square theta. So now we are about to prove that sine theta equals to sec square theta. Now we can observe, rather than using theta, we are using x now. I mean tan x equal to sec square x now. Given that tan x sin x divided by cos x equal to cos x multiplied by cos x minus sin x multiplied by minus sin x, all divided by cos square x equal to cos square x plus sin square x divided by cos square x equal to 1 all over cos square x. Then we arrive at sec square x, which is the reciprocal of cos square x, which is cos square x. Then for the derivative of cosecant, given that cosecant x equal to the derivative of 1 all over sin x equal to sin x multiplied by 0 minus 1 multiplied by cos x divided by sin square x equal to minus cos x all over sin square x equal to minus cos x divided by sin x multiplied by the reciprocal of sin x equal to minus cot x equal to cosecant x. Derivative of secant. Secant is the reciprocal of cotangent x. So now the derivative of secant x equals to the derivative of 1 all over cosec x, which is equal to cos x multiplied by 0 minus 1 multiplied by minus sin x divided by cos square x equal to sin x divided by cos square x equal to sin x divided by cos x multiplied by 1 all over cos x, which is all equal to tan x multiplied by sec x. Now we go into the derivative of cotangent. Cotangent is the division of cos divided by sine. Now the derivative of cotangent x equal to the derivative of cos x divided by sin x, which is equals to sin x multiplied by minus sin x minus cos x multiplied by cos x divided by sin square x equal to minus sin square x minus cos square x divided by sin square x equal to minus, we open bracket, sin square x plus cos square x close bracket divided by sin x equal to minus 1 divided by sin square x, all equal to minus cosecant square x. So we have seen that the proof of cotangent x equal to minus cosecant square x. So just a summary of what we've been doing so far, we can see that given a function y equals to sine theta, then the derivative of the function will be cos theta. If a function is also given as y equals to sine theta, the derivative of that function will be minus sine theta. And finally, if a function is given as tan theta, the derivative of tan theta will be square theta. I would like to leave us with a practical problem, and the practical problem is that we should prove that if y equals to function of theta equals to sine theta, then prove that the derivative of the function, which is the dy dx, equals to cos theta. So thank you for your time. God bless you.